Good morning, students. Welcome to video lecture on microwave and optical fiber communication. Subject code U18EC709. Topic EH plane T, or it is also called MASIC T. EH plane, hybrid T, or MASIC T junction. The EH plane T junction is found by attaching two simple waveguides, one parallel and the other series. A rectangular waveguide which already has two ports, and this is also called MASIC T, hybrid T, or 3dB coupler. That is, a primary waveguide is already having ports 1 and 2, and a H-arm port 3 is attached and E-arm port 4 is attached to form EH plane T junction. Here EH plane T junction is a 4-port device. So the S matrix is of the order of 4 by 4. That is, it starts from S11 to S44. Always port 3 is H-arm, port 4 is E-arm. And here it obeys the property of H plane T and E plane T. That is, when some micro power is applied between applied at port 3, it is divided equally between the ports 1 and 2. That is, it obeys the plane of symmetry property of S13 is equal to S23. And in the same way, when some microwave power is applied at port 3, it is applied at port 4, that is at E-arm, it is divided equally between the ports 1 and 2 with opposite in phase. With opposite in phase. That is S2, 4 equal to S14. That is, fourth port is the input port. If the power is applied at port 4, it is divided equally between ports 2 and 1 with opposite in phase. That is the minus sign. That is, once again, I will rewrite S24 is equal to minus of S14. Here, port 1 and port 2 are called collinear ports. Port 3 is H-arm, port 4 is E-arm. H-arm is also called summing port, and E-arm is also called difference port or series port. Let us move to the derivation of EH plane T scattering matrix derivation. It starts with the first point. S is a square matrix of the order of n by n. Here it is a 4-port device, so S matrix is 4 by 4. And from the plane of symmetry, just now we discussed S13 is equal to S23 and S24 is equal to minus of S14 given by equations 2 and 3. And here one more point is you can observe, I will show here, when power is applied at port 3, it is divided equally between the ports 1 and 2. And when power is applied at port 4, it is divided equally between port 1 and 2. Means here if power is applied at port 3, then there is no power received at port 4, and if power is applied at port 4, no power will be received at port 3. What it means is uh, 3 and 4 are isolated ports. 3 and 4 are isolated ports. So we can rewrite the property as S34 S43 is equal to 0. Let it be equation number 4. And the one more important property of S matrix, symmetric matrix property, S12 S21 S13 S31 S14 S41, and like that we get equation number 5. And the same as we did in the case of H plenty and E plenty, uh, 3 and 4 ports are for applying input. So in general we consider port 3 is perfectly matched with the junction, so S33 is equal to 0, and in the same way uh, port 4 is perfectly matched with the junction, so S44 is equal to 0. And applying all these properties and rearranging, we get equation, the modified equation of S matrix as given by equation number 7. And once again we apply the unitary matrix property as we did in the case of E plenty and H plenty, and it is the S matrix obtained in equation number 7. S into S conjugate is equal to I, and once again what we did in the case of earlier is R1 C1, R2 C2, R3 C3, R4 C4. This type of expansion we are going to do to further proceeding of derivation. And here by expanding along R1 C1 we get equation number 8. Along expansion along R2 C2 we get equation number 9, and along R3 C3 we get equation number 10, and R4 C4 equation number 11, and R4 C1 let it be 11a. And here you can observe from equation number 10 you can determine the value of S13 as 1 by root 2, and the value of S14 as once again 1 by root 2, and from equation number 11a, here S14 is not equal to 0 uh, because the power is applied at port 4, it is divided equally between the ports 1 and 2. Here we can write the relation as this term is not equal to 0 means this term should be equal to 0 means here by neglecting the complex conjugate S11 is equal to S12. This type of relation we are going to get. And here once again by comparing first two equations S14, 13 and 12, by comparing the first two equation we get the interrelation as S11 is equal to S22, and by substituting all these interrelations once again in equation number 1 uh, and after rearranging we get the S matrix for H plenty junction given by S 1 by root 2 1 by root 2 1 by root 2 minus 1 by root 2 1 by root 2 1 by root 2 1 by root 2 minus 1 by root 2 0. This is the S matrix. You can write it in the form of reflected and instant powers, that is B is equal S into A. Here by knowing the values of instant power you can calculate the reflected power, or by knowing the reflected power you can calculate the instant power, that is in matrix notation B is equal to S into A. Applications of massivity can be used to measure an impedance, can be used as duplexer and as mixer, and many more applications. Thank you. We will meet with the next lecture.